Alright, so today we have task number 9, msfvenom. This task is part of what the shell module, which is a prerequisite of upload vulnerabilities module, which is part of the complete beginner path on TryHackMe. So msfvenom, the one-stop shop for all things payload related. Part of the Metasploit framework, msfvenom is used to generate code for primarily reverse and bind shells. It is used extensively in lower level exploit development to generate hexadecimal shell code when developing something like a buffer overflow exploit. However, it can also be used to generate payloads in various formats, .exe, .aspx, .word, .py. It's this later function that we will be making use of in this room. There is more to teach about msfvenom than could ever be fit into a single room, let alone a single task. So the following information will be a brief introduction to the concept that will prove useful for this room. The standard syntax for msfvenom is as follows. Pretty simple. We have the msfvenom with the P flag, and then we choose a payload and then options for it. For example, to generate a Windows 64-bit reverse shell in an exe.exe executable format, we could use the following: msfvenom P flag, and then from Windows x64 shell reverse TCP, we go for F flag, file to be exe, output to be a shell.exe, and then the local host is listening IP and the local port is a listening port. Here we have the example actually filled in with the IP and the port. No platform selected, choosing a module, alright, Windows for the payload. No encoder specified, outputting raw payload. Payload size 510 bytes. Final size of exe file is 7168 bytes. Saved as shell.exe. Here we are using a payload and 4 options. F flag specify the output format. In this case, that is an executable. O flag, the output location and file name of the generated file. Current directory, exe. L host specify the IP to connect back to. When using TryHackMe, this will be your Tune 0 IP address. If you cannot load the link, then you are not connected to the VPN. L port, the port of the local machine to connect back to. This can be anything between 0 and 65535, the entire range of IP ports that isn't already in use. However, ports below 1024 are restricted and require a listener running with root privileges. Staged versus stageless. Before we go any further, there are another 2 concepts which must be introduced: stage reverse shell payloads and stageless reverse shell payloads. Stage payloads are sent in 2 parts. The first part is called the staged. This is a piece of code which is executed directly on the server itself. It connects back to a waiting listener, but doesn't actually contain any reverse shell code by itself. Instead, it connects to the listener and uses the connection to load the real payload, executing it directly and preventing it from touching the disk, where it could be caught by traditional antivirus solutions. Thus, this payload is split into 2 parts: a small initial stager, then the bulkier reverse shell code, which is downloaded when the stager is activated. Staged payloads require a special listener, usually the Metasploit multi-handler, which will be covered in the next task. And stageless payloads are more common. These are what we've been using up until now. They are entirely self-contained in that there is one piece of code which, when executed, sends a shell back immediately to the waiting listener. Stageless payloads tend to be easier to use and catch. However, they are also bulkier and are easier for an antivirus or intrusion detection program to discover and remove. Staged payloads are harder to use, but the initial stager is a lot shorter and is sometimes missed by less effective antivirus software. Modern day antivirus solutions will also make use of the anti-malware scan interface AMSI to detect the payload as it is loaded into memory by the stager, making staged payloads less effective than they would once have been in this area. We have the Metapreter. On the subject of Metasploit, another important thing to discuss is a Metapreter shell. Metapreter shell are Metasploit's own brand of fully featured shell. They are completely stable, making them a very good thing when working with Windows targets. They also have a lot of inbuilt functionality of their own, such as file uploads and downloads. If we want to use any of the Metasploit's post-exploitation tools, then we need to use a Metapreter shell. However, that is a topic for another time. The downside to Metapreter shell is that they must be caught in Metasploit. Payload naming conventions. When working with msfvenom, it's important to understand how the naming system works. The basic convention is as follows: the operating system, the architecture, and then the payload. Here is the example. The operating system is Linux, the architecture is 32 bits, and shell reverse TCP is the payload. This will generate a stageless reverse shell for an x86 architecture Linux target. The exception to this convention is Windows 32-bit targets. For this, the arch is not specified. For example, Windows without the architecture, right? And we just fill in the payload that we want to use. For a 64-bit Windows target, the arch would be specified as normal. Let's break the payload section down a little further. In the above examples, the payload used was shell reverse TCP. This indicates that it was a stageless payload. How? Stageless payloads are denoted with underscores. The staged equivalent to payload would be shell reverse TCP. So as you can see, we used shell and then underscore reverse TCP in the same one, stageless. And staged is from the shell directory, we used reverse TCP. As staged payloads are denoted with another /. This rule also apply to Metapreter payloads. A Windows 64-bit staged Metapreter payload would look like this: Windows architecture, Metapreter, and reverse TCP, right? Staged payload. And this one is stageless. A Linux 32-bit Metapreter, which with a stageless payload would look like this: Linux architecture and then the payload. Aside from this MSF console manual page, the other important thing to note when working with msfvenom is msf-list payloads. This can be used to list all available payloads, which can then be piped into grep to search for a specific set of payloads. For example, here we are looking only for the operating system, a payload for Linux that's 32-bit architecture, and for a Metapreter, right? We want to access a shell in MSF console. This gives us a full set of Linux Metapreter payloads for 32-bit targets. Answer the questions below. Generate a staged reverse shell for a 64-bit Windows target in an .exe format using your TryHackMe Tune 0 IP address and a chosen port. Okay, so for this, we have to use this entire command. And then what is the shell? Yeah, it's a staged reverse shell. So for staged, we have to go like this. Yeah, this is good. All right, we go for .exe, and here we would fill in the IP of our machine and any port that we want. Yeah, So is this command. Okay, which symbol is used to show that a shell is stageless? It's an underscore. Stageless. What command would you use to generate a staged metapreter shell? Okay, let's pick this up. Let's place it here. And then let's delete this and say 10, 10, 10, 5. We can see in the what is needed. All right, now going back here. The format for the shell is ELF. This means that for -f is ELF. The output file name should be shell. All right, and then we should go for staged, which means we go like this. And it's a Linux target for a 64-bit architecture. And then we have a shell reverse TCP. Yeah, should be this command. Shell reverse TCP. Actually, here is not shell, is metapreter. Yeah, that was it. So we need to generate a staged metapreter reverse shell. msfvenom -p Linux 64, right? And then metapreter directory, because it's a staged shell. Then / reverse TCP. Then for the format, it's an ELF. For the output is shell. And then lhost provided. And then lport provided again. Cool.